We're going to be looking at sedimentary rock, oil, and coal formation. Today, you're just particularly looking at oil and natural gas formations. This is a review. I won't go over the review section right now, but you can go back over and look at that. I do have this part right here. This is where I'm going to start with you, but you can look at the other things as well. So let's go ahead and look at this. So we have fossil fuels. So we have three basic types of fossil fuels. We've got coal, oil, and natural gas. Something to keep in mind is that energy for fossil fuels originates from interactions between the sun and producers. So that's where it has to originate from because the producers create their own energy. So they're harnessing the energy of the sun. All that energy from the sun is packed away inside those producers when they decay. They're also packed into the consumers, the small consumers that would be eating the plants as well. So those things are the basic building blocks of the fossil fuels. So we'll start by watching a brain pop video. Here it is. Once it decides to log in, there we go.
Dear Tim and Moby, my teacher said we're running out of fossil fuels. Does she mean gas? From Maddie. Hey, Maddie. Natural gas, along with coal and oil, are all known as fossil fuels. We use fossil fuels to heat our homes, run our cars, and power industrial plants. And, more importantly, we're using them now to cook these hot dogs. Oil and natural gas are similar because they're both types of petroleum. Oil is the liquid form, natural gas is the gaseous form. Petroleum comes from the remains of marine microbes, plants, and animals from millions of years ago. That's right, Moby, dead plants and animals. Yeah, well, enjoy your hot dog. Anyway, when these organisms died, their bodies began to decay. They sank to the bottom of the ocean or swamp they were living in. Over time, they were covered with layers of sand and then stone. Heat and pressure went to work on them over millions of years. Eventually, they were transformed into pockets of petroleum in the earth. That's why we call them fossil fuels. They come from prehistoric organisms. Miners use big drills and pumps to get deep into the earth's crust and find petroleum. These drills create underground wells, both on land and offshore. The oil and natural gas that come from petroleum are really valuable resources. The gasoline that powers cars is made from refined oil. And if you have a gas stove, then you've seen natural gas in action. Both oil and gas can be burned in power plants to generate electricity. Another type of fossil fuel is coal. Coal was also once living matter. Yeah, this might sound familiar. Prehistoric plants died and sank into the swamps and bogs. Over time, they were covered with layers of rock and earth. The pressure became so great that it slowly squeezed them into a solid. Coal is extracted by digging large mines, both near the surface and deep in the earth. Coal was used heavily as a fuel source during the Industrial Revolution and is still commonly used today. Fossil fuels are incredibly efficient energy sources. Just one tank of gasoline can take a car hundreds of miles. They're also pretty convenient because they don't need too much processing. Unfortunately, burning fossil fuels releases lots of harmful byproducts. This creates pollution, affecting the quality of the air we breathe. You know this if you've passed coal-burning smokestacks or opened a car window while stopped in traffic. Burning fossil fuels also releases carbon dioxide, which is one major cause of climate change. We're already experiencing many of the effects of climate change. Extreme weather patterns like terrible hurricanes and storms, worsening drought conditions which lead to frequent wildfires, rising sea levels and shrinking ice caps, and the destruction of animal habitats. But even if they didn't have such harmful effects, fossil fuels are a non-renewable resource. That means once they're used up, they're gone and can't be replaced. And we're using fossil fuels much faster than the Earth can produce them. At our current rate of consumption, we probably won't have enough oil and gas to last us through the next century. Fossil fuels still account for about 60% of the energy used in the world. It's hard for people to change. Luckily, there are cleaner alternatives to fossil fuels. Lots of research is being done on developing renewable energy. solar power, a clean, cheap way to capture the awesome power of the sun, and nuclear power, a way to channel atomic energy. Tapping other sources of energy like water and wind are also alternatives. Geothermal energy harnesses the internal heat from the Earth itself. And keep an eye out for fuel cells that run on hydrogen. Ew. In order to conserve fossil fuels, Moby has volunteered to eat his hot dogs raw from now on.
Okay, let's go ahead and go back to the So then there's another video. I'm not going to play that here because I'll make this video too long, but there's another video on fossil fuel formation.
Fossil
Oh,
fuels.
just kidding. There we go. All right, so coal formation, you learned about that yesterday. It comes from plants in swamps. I'm not going to go over that too much because that's something you went over yesterday. This is just some diagrams as well. So here's what I'm getting into. So petroleum formation, process for oil and gas formation. What this is it's from the remains of microscopic ocean plants and animals. Okay, so it comes from the ocean, plants and animals. And they settle and become buried within seafloor sediments. So sedimentary rock forms over them. So they're sealed, just like in the coal process. They're sealed over by sediment and more sediment and more sediment and more sediment until it's like sedimentary rock forms on top of them, sealing them up, not allowing bacteria to get to them and things that would normally help in the decaying process. So they sit down there, kind of just stewing away under pressure because of the many layers over them and the heat from the earth as well. So many layers of sediment accumulate, creating intense heat and pressure. Intense heat and pressure turn the remains into oil and natural gas over millions of years. All right, so I drew this. Don't make fun of my art, and just did it pretty quick. So here is an ocean. There's some ancient plant life. There's microscopic plant organisms here. Those little dots are supposed to symbolize that. There's a sawfish, an ancient animal, and then some plant. I don't know, just try to draw something. And what happens? Well, they die. And then they sink to the bottom and get covered up by sediment and sediment and sediment until it's that sedimentary rock over it. So there's my layers of sedimentary rock covering over the remains of the plants and animals from the ocean. And then heat and pressure act on this little thing right here, which was the remains of the plants and animals. And because of the heat and pressure, it becomes oil. And then it comes to the present day where we drill down and just suck it up and get that oil. So that's a pretty rudimentary kind of way of looking at it, but that's it. Okay, so here's another diagram here. Tiny sea plants and animals died and were buried in the ocean floor. And then sedimentary rock forms over them, and millions of years occur, heat and pressure occur, and then we're able to extract the oil from that now. Okay. The next thing I'd like to share with you is this. This is a page of notes. There's a blank copy right underneath it. Here are the notes that you will be filling in. It occurs from 300 to 400 million years ago, and there's a lot of plant life and animal life, and then they die and they fall to the bottom. And then layers upon layers upon layers of sedimentary rock form on top of them, and then today we are able to drill down and get that oil. So then the second part, millions of years ago, microscopic plants and animals died and fell to the bottom of the ocean floor. Over time, many layers of sediment form. Intense heat and pressure turn the remains into natural gas and oil. All right, that's your work, and then there's a quiz at the end. Thank you so much, guys, and enjoy your day.